Okay, so let's try to find a tangent to a curve. Problem says find A, the coordinates of the point on the curve y is equal to 3x squared plus 2x plus 1, where the tangent to this line is parallel to 4x plus y is equal to 5. And after we've done that, it wants us to find the equation of the normal to this tangent at this point. Okay, so what we're going to do is try to get a good idea of what it is that we're looking at, and then we'll come back and try to solve this problem. So this curve, this line this curve that you see here is actually y is equal to 3x squared plus 2x plus 1. So this is the curve. And we're looking for a tangent to this curve that is parallel to a given line. I want you to keep in mind that what a tangent is a straight line that touches one point. But this tangent line could be anywhere. Okay, it could be anywhere unless we're given that point. For example, right here, this line touches just one point. It's not drawn exactly. So it could be there. It could be that line. It could be this line. This touches one point. Okay. It could be this line. This touches one point. Okay. So normally we're given some information to know which tangent line we're looking for. Normally they give us a point, tangent on a curve at a point, so forth and so forth, right? In this case, what we're given is something else. In this case, what we're given, so this is our curve, and this is the line. This is a line that is given as 4x plus y is equal to 5. And what do we know about this line? We know that this line runs parallel. Okay, this line runs parallel to the line that we're looking for. So now we can eliminate the other tangents because the other arbitrary tangents that we were choosing, they don't run parallel to this. So what we're looking for is going to be something that runs parallel to this. So maybe something that looks like this. Okay, now again, I'm not measuring if this is parallel, but we're looking for something that looks like this. This would be our tangent that runs parallel to this line. Now, we're not being asked to find the tangent. We're not being asked to find the equation of the tangent. We're being asked to find the coordinates where the tangent touches this curve, right? So that would be somewhere around here. So argument's sake, again, this isn't drawn to scale, all right? Maybe somewhere around there. And then furthermore, we're being asked to find the normal line. Now what a normal line is a line that's going to run perpendicular, 90 degrees, okay? From this very same point. So we're looking at a line that goes something like this, where this is 90 degrees. Right here, 90 degrees. And so we're then being asked to find the equation of this line. All right, so that's what we're being asked to do. All right, so let's get busy. So here we go. What do we know? We know the coordinates of the point on the curve is what we're looking for. Okay, so the curve is f of x, which is y, is equal to 3x squared plus 2x plus 1, where the tangent line is parallel to 4x plus y is equal to 5. So what I know is that when I find the first derivative of this, I'm going to find the gradient of the tangent line. So the first derivative going to be represented as f prime of x, which is dy dx. And so that's going to be 6x plus 2. How did I get 6x plus 2? 2 multiplied by 3. And then x raised to the 2 minus 1 power. 2 minus 1 is 1. So it's 6x to the first power, which is just 6x. And if I have 2x, then I'll take just the 2. That's how I differentiate. All right. So now normally what I would do if I was given a point, I would say at a certain point, I would put that point in here to find the gradient, the slope. But instead, we have to work backwards because we have to then find the slope. Now, how can I find the slope? Okay, this is all of the tangent line. All right. So what I do know is that the line is parallel to 4x plus y is equal to 5. So when I rewrite that in the slope-intercept form, when I take this 4x over here, so it'll become minus 4x plus 5. Okay. So now I know that the slope of the parallel line is right here, minus 4. But if the slope of the parallel line is minus 4, then the slope of the tangent line is also minus 4. Because when two lines are parallel, their slopes are equal. So I'm going to then say m of the tangent line, which means the slope of the tangent line is also equal to minus 4. So what am I going to do with that now? What I'm going to do now is I'm going to equate that to this, because this is the gradient. So 6x plus 2 is equal to minus 4. So now I can solve for x so I can know the x value of the point that I'm looking for. And when I do that, I'm going to get 6x is equal to minus 6. I transpose the 2, take it over, it becomes minus 2. And therefore, x is equal to minus 1. So I now know the x coordinate, the x value of the coordinate that I'm looking for. So what I'm going to have is minus 1 something. We got to find that something. So we have to find the y value. So what I'm going to do now is I'm going to substitute x is equal to minus 1 into the original f of x. So f of x was 3x squared plus 2x plus 1. And when I do f of minus 1, what that means is wherever I see x, I'm going to plug in minus 1. When I do that, I get 2. Good idea to pause the video right here and see if you get the same thing. But basically, you're going to put minus 1 wherever you see x. And when you work that out, you're going to get 2. So this is the answer to part A. The answer to part A is -1, 2. All right. So let's move on to part B. So now I'm asked to find the equation of the normal at that point. So remember, the point that we're talking about is -1, 2. At that point right here, there's a normal line, and we want to find the equation of that line, which means at that point, we're also on that line. So we're on the tangent line, we're on the normal line, and we're also on the curve at that point. Okay. So again, what we know is the equation of a line is y is equal to mx plus c. Do I know m? Well, these two things are perpendicular. How do I know that? Because it says normal. If they're perpendicular, then m1 multiplied by m2 must be equal to -1. Another way of saying that is that if I know one of the m's, then I should be able to tell the other one. All right, and one of the m's is -4. So m1 in this case, which is the m of the tangent, right, is -4. So m1 is equal to -4. So m2 must be equal to 1/4. How do I know that? Because when I multiply these two, I'm going to get -1. And there's an easier trick to do this. For example, all you do is take a negative reciprocal, right? So again, if I have -5 for one of the m's, then what's the reciprocal of -5? It is 1/5. But remember what I said, we're going to take a negative reciprocal. So if this was negative, this is going to be positive. So m2 must be 1/5. When we multiply them back, we'll get -1. Always remember that. All right, great. So now I know that the m for the tangent line is 1/4. So I can come in here and I could say y is equal to 1/4 x plus c. Now I've got to find c though. I can't leave it like this. I got to find c. That's where this comes in again. Because I know this point is on the line. So what I'm going to do is I'm going to substitute these points into this equation. So where I see y, I'll put 2. See, 2 is the y value. So I'll say 2 is equal to 1/4 and x is -1 plus c. And you will now realize that there's only one unknown in this equation. So when I solve for this equation, when I solve for c, what I'm going to get is 2 plus 1/4, which is 9/4. Hence, my answer is y is equal to 1/4 x plus 9/4. Of course, I could rewrite this as y is equal to 1/4 x plus 9, but this should suffice right here as your answer because we're looking for the equation of a line and this is a form y is equal to mx plus c. All right. So I hope this was very helpful to you. Hit a thumbs up if it was, leave any comments, questions if you have on there. And I have lots of other courses on here that will help you with any of the things we had here. You probably want to brush up on some of the plotting, linear functions, and so forth. But I hope this was helpful. Have a good one.